Hello students, today we will learn interference in thin film due to transmitted light. Let us consider a thin film of refractive index mu and uniform thickness T. Let a monochromatic beam of wavelength lambda is incident on the surface at angle of incidence I. As the monochromatic beam is traveling in the rarer medium, it will be refracted into the denser medium, so it will bend towards the normal. At the denser surface, a part of the refracted beam emerges into the rarer medium and another part of the refracted beam is reflected back into the denser medium. The reflected beam BC on further reflection from the denser surface emerged out into the rarer medium as beam DF. Since the film is excessively thin, the two beams BE and DF are coherent beams. The two coherent beams BE and DF superimposes to produce interference patterns which are observed on the film in the transmitted system. When the reflected beam travels a distance BC plus CD in film, the transmitted beam travels a distance BN in air. Hence, the optical path difference between coherent beams BE and DF is given as optical path BC plus CD in film minus optical path BN in air, which can be further written as delta equal to mu BC plus CD minus BN, because for air the refractive index is 1 and for film the refractive index is mu. The path difference between coherent beams BE and DF is worked out to be delta equal to 2 mu t cos r, where r is the angle of refraction. Since the beam BC is reflected from the denser surface, hence according to Stokes' theorem, it will suffer a phase change of pi. Since the beam CD is reflected from the denser surface, it will further suffer a phase change of pi. Hence a total phase change of 2 pi is introduced. On the other hand, the beam BE is transmitted into the rarer medium, hence no Stokes' theorem is applicable. Therefore, the optical path difference between coherent beams BE and DF remains unchanged as delta equal to 2 mu t cos r. To satisfy the condition of constructive interference or maxima, the path difference between coherent beams BE and DF will be 2 mu t cos r equal to 2n lambda by 2 for n equal to 0, 1, 2 and so on. On the other hand, to satisfy the condition of destructive interference or minima, the path difference between two coherent beams will be equal to 2 mu t cos r equal to 2n minus 1 lambda by 2 for n equal to 1, 2, 3 and so on. From this we conclude that in the constructive interference, a bright fringe in transmitted system will be a dark fringe in reflected system. That is, the fringes are exactly complementary. Similarly, the fringes are also complementary in transmitted and reflected system.